Hey everyone, so welcome to part 3 and the final part of this video series on solving stoichiometry problems. In the previous videos, we have looked at the types of stoichiometry problems, including moles to mass problems and mass to moles problems. In our final example, we're going to go through a mass to mass stoichiometry problem. So, in this example, here's what we are asked. What mass of ethane, or C2H6, is needed to react completely with 18 grams of oxygen? Again, to save time, I have written the equation for you here, and it is already balanced. Now, for an equation like this, while you would not be expected to name ethane, you may be expected to recognize that when you react a carbon and hydrogen compound, or a hydrocarbon, with oxygen, that's a combustion reaction. And if I'm telling you reacts completely, you would also be expected to know that the products are carbon dioxide and water. Just as a heads up, that is how we would set up that equation and how we would predict the products and balance it. So, what mass of ethane is needed to react completely with 18 grams of oxygen? So, we've set up our equation, we've predicted our products, and we've balanced it. Now what we want to do is set up our given and our unknown. So what we are given is the mass of the oxygen gas, or the mass of O2. We know that that's 18 grams, right? We're assuming that we have an 18 gram sample of oxygen, and it's going to react completely with an unknown mass of ethane. And that is our unknown, the mass of ethane, or C2H6. So that means that this is a mass to mass problem. Remember in the previous part, I mentioned how you cannot compare masses in a stoichiometry problem because masses do not confirm the amount of atoms in a compound. That's what we need moles for. So our very first step is going to be taking our given mass for oxygen and converting that into a mole value for our first given compound. So we first will need to find the moles of oxygen. So again, we're using our same formula, moles equals mass over molar mass, and I just like to write it like this, where the small m means mass, and then two m's, or two big M's, means molar mass. So I know that there's 18 grams of oxygen, and then the molar mass here is 32 grams per mole. This may trip people up, and I want to be super clear about this because remember that oxygen gas is O2. Oxygen is a diatomic molecule. While the molar mass of a single oxygen atom is going to be 16 grams per mole, remember that this is not a single atom, this is a diatomic element, which means there's two atoms, which means 16 times 2 is 32 grams per mole. So keep that in mind. Now, I've set up my mole equation and I want to find the number of moles. So 18 grams divided by 32 grams per mole will equal 0.5625 moles of oxygen. I'm not going to round this yet. I'm leaving this as is, right? I don't want to round anything too early in my solution, otherwise it could give me a wrong answer. I'm always going to wait until the very end to round anything. So, right now, we have the moles of oxygen. But we want to find the mass of ethane. So, what our next step would be to convert the moles for oxygen into a value that gives us the moles of ethane. And we can do that by looking at the molar ratio of ethane and oxygen. So once again, we're going to set up our conversion factor like in the previous examples. And again, I'm going to be super clear about this because I think this is what was tripping a lot of people up. was that the way that you want to set up your conversion factor is so that the units of what you already have will cancel out to give you the units of what you don't have. Which means if we have moles of O2, then we want the moles of O2 to cancel us out and leave us with the moles of ethane. So I'm always going to go back and look to my coefficients. I see a 2 and a 7. And what this means in this reaction equation is that for every 2 moles of ethane, you need 7 moles of oxygen to react completely and have a complete combustion reaction. For every 2 moles of ethane, you need 7 moles of oxygen. That's the molar ratio. And we can set up our conversion factor that way by writing 2 moles of ethane over 7 moles of oxygen. And this conversion factor is the same as saying there are 2 moles of ethane per every 7 moles of oxygen. That's why that makes sense. And then our added test is to make sure those units cancel out, right? And because here the moles of O2 are in the denominator, they will cancel out these moles of O2 in this unit. So we've set up our conversion factor, and then when you solve this, 0.5625 moles times our conversion factor of 2 over 7, you will get a rather long decimal. Or 0.160714285 moles of ethane. I'm going to save that in my calculator, and I'm not going to round that yet because I don't want to accidentally give myself a wrong answer down the road. I'm going to wait until the very end to round anything. So I now know the number of moles of ethane. And if I have moles, then I can find mass, which is what we want because this is a mass to mass problem. So for ethane, we're going to rewrite our standard equation, moles equals mass over molar mass. Once again, we want to rearrange this equation, and we can do that by multiplying both sides of the equation by molar mass. I'm just doing that in a different color so that it's super clear. Then what you get is you will have the mass being equal to the moles times the molar mass. So if we have 0.160714285 moles times the molar mass of ethane, you guys would have to look this up on your own, 30.07 grams per mole. And the moles cancel out when we multiply these values, right? Because we're looking for just mass in grams. And then when you multiply these together, you will get 4.83267 should be an 855 grams of ethane. And now that we're at the very end, now I can round it. Now that I'm confident that rounding too early won't give me a mistake. So I always like to round to 2 decimal places. Some teachers would have you track significant figures and then use that to know what you need to round to, but I don't think that's very important. I just want to focus on consistency, 2 decimal places wherever you can. So 4.83 grams of ethane. And that there is our final answer. So, to answer our question of what mass of ethane is needed to react completely with 18 grams of oxygen, we now know that when you have 18 grams of oxygen, if you want it to react completely and have a complete combustion reaction, you will need 4.83 grams of ethane. And we determined that by looking at our balanced equation looking at the molar ratio of ethane and oxygen based on the moles that we calculated for each. Right, we took a mass value, converted it to moles, converted the mole value of one compound to the mole value of another, and then we took that number of moles and used that to solve for a mass. So that has been all three different kinds of stoichiometry problems. There is mole to mole problems, which I didn't show you. There is mole to mass problems, mass to mole problems, and mass to mass problems. So please, if you are not comfortable with stoichiometry, please make sure to ask me. You're always welcome to email me to ask me questions. These skills are very important as they will come up throughout the rest of the course, right? In future units, you will still see stoichiometry and this kind of proportional reasoning.